Alan has a background in kinesiology, specializing in biomechanics and physiology. He is currently a defense scientist at the Defense Research and Development Canada in Toronto, working in the Human Systems Integration section. He began his career there where he conducted thermal physiology research to inform the development of protective clothing and equipment for extreme cold or hot environments, as well as developing a cold exposure survival model for search and rescue authorities. Recently, he was the scientific authority for the Canadian Forces Anthropometric Survey, measuring personnel using both traditional and 3D scan methods. Data obtained during the survey is currently being used to inform design, development, evaluation, and acquisition of clothing, equipment, and platforms for the Canadian Armed Forces. So we hope that you're going to enjoy this webinar today. We're going to run it for approximately an hour. Alan is going to talk through the presentation. If you have any questions, please put them into the Q&A or the chat box, and I will be monitoring the questions as they come up. If appropriate at that time, we will discreetly interrupt Alan with his natural path, or perhaps we'll wait till the very end, so whatever kind of has the natural flow to it. But please put up your questions if you have a question, and we'll hand it over to Alan. Thank you, Alan, so much for joining us today. We really appreciate you taking the time for this. So over to you.
Great. Well, thank you for inviting me to do this presentation. As mentioned, I've been floating around the field for quite a number of years. I did my Bachelor of Science back in 1987 in kinesiology, and I've been working in this absolutely amazing field of, within defense research and development for, getting close to 30 years. That's really painful to think about, but it's such a fantastic opportunity, and I'm really happy just to be able to open up a little bit of the world that I work in, show you how we apply human factors engineering, ergonomics, anthropometry within a military context. And then hopefully some of the material that I present today, some of the tools that we're developing will work their way out of the defense world and end up on your laptop or your guidelines and help you in the work that you do as well. So again, just a really quick background. Over a longer career, you sort of bounce around and do a lot of things. You have many lives. When I first graduated, I ended up working in Ottawa, a defense research establishment in Ottawa, where I worked in thermal physiology. So you can see on these top screens, two screens, I spent a lot of time being very cold, or as in this picture, making people very cold. The work that came out of that was looking at protective clothing, so tents, parkas, and various insulation to keep soldiers protected in austere environments. But we also developed a cold exposure survival model. So this is a model that's used by search and rescue authorities worldwide, actually, to predict survival times based on accidental cold water immersion, or even if hikers are lost on land. And the anthropometric data is actually, I can talk about that a bit later, but I actually use that in the survival model as well, because body size, body fat content, etc., is very important for thermal modeling. However, now I'm more in a physical ergonomics field, where I've been doing a lot of work on marksmanship, weapon recoil and muzzle movement. The SETS project I'll talk about is developing ergonomics tools and techniques. So we use the anthropometry more in the physical domain. One of the other things that keeps me very busy is aircrew accommodation modeling. You may or may not be aware, but within the Royal Canadian Air Force, all aircrew or pilots are anthropometrically screened. So what that means is you could be the best pilot in the world, the most skilled, the brightest, sharpest reflexes, but if you don't fit in certain aircraft, you'll never actually fly that airframe. So part of the work that we're doing here is trying to give information to the Canadian Forces so that get smarter decisions on future airframes, future vehicles, future clothing, to ensure that we're actually matching or designing or specifying these items to match our population. So really briefly about Defense Research and Development Canada. We're a special operating agency, so I'm a civilian, but we're co-located with the Canadian Forces Environmental Medicine Establishment. So I work hand in hand with uniformed members of Canadian forces. And our objective and mission is to ensure Canadian forces of the future remain technologically relevant or prepared and relevant, and to provide S&T leadership. And we do that for both defense and security. Now there's 8 centers within DRDC. Each center has its own speciality and mandate. Within Toronto, and we're located up in Downsview, just north of Yorkdale Shopping Mall, if anyone can reference that. We're the Center for Human Effectiveness Science and Technology. So we look at the individual, we look at humans interacting with technology, which is the field I work in, and also we look at humans in teams, so command and control, trust in teams, etc. That's another area that we work in. Now we are researchers, so we are very small on the practitioner side. We do go out and we do the human factors evaluations, but our real mandate is to do the science and develop tools, methods, techniques that we can hand over to the practitioners who are located within national defense, so to help them do their jobs better. In particular, I work quite closely with ADM Materiel, who does a lot of, who does the acquisition for Canadian forces. So if they're specifying ships and planes and clothing, etc., we would provide advice to them to make the best decisions possible. So the presentation overview, this is just a really high level, 30,000 foot view, but I'd like to just introduce you to a project that I'm leading called Comprehensive Ergonomics Tools and Techniques. We just call that SETS. Within that project, we conducted an anthropometric survey of the Canadian forces in 2012. We're developing tools to actually make good sense of this data. The worst thing you can do is just hand over a big pile of data to someone who may be trained in safety systems but not anthropometry, and have them ask them to make smart decisions. So developing good tools to help with the decision making is part of the process. Encumbered anthropometry, we always say we don't fight in our underwear. Our soldiers wear a lot of very heavy, very restrictive protective equipment. So we need to account for this equipment for sizing and fitting of the soldier, but also the soldier interacting with the environment or vehicles or platforms, whatever that they're working with. We also have a component on soldier burden and mobility. Again, once you're encumbered, you're going to slow down and have difficulty moving, so we're doing research in that area. And finally, we'd like to develop a strong capability in virtual modeling so that we can support our field trials and actual fit testing that we do with live humans. Right, so the Comprehensive Ergonomics Tools and Techniques. This is a project that we started, it's fairly recent, about end of 2011. So we're just a little over 3 to 4 years that we've been working on this. But this was to basically reestablish a capability within DRDC to get back in the business of physical ergonomics. We had drifted away a bit. We're always strong in physiology, aerospace, undersea, social psychology, but we were starting to lose some of our capability in physical ergonomics. So again, you can read the slide here. I don't really like reading slides, what you can see, but we're essentially all about developing tools and establishing a capability to do the research to develop these tools. So there's several components to the project. One, first off is defining our population, and that's through the anthropometric survey, parametrizing and modeling encumbrance, digitizing workspaces, etc. And our motto that we have down at the bottom of the screen there is, we like to equip our soldiers to fight. We shouldn't expect our soldiers to fight their equipment. They have enough problems without dealing with poorly designed or poorly fit equipment. So again, here's just a quick overview of the major components of the SETS project. And that's pretty close to what I mentioned before with the addition of digital human modeling capability at the bottom. So essentially going from 0 to 100 in a few short years, the first thing we needed to do was build a large laboratory and populate it with the tools, etc., that we need to do our research. So we have 2 large, almost warehouse-size rooms that we've taken advantage of large facilities being decommissioned, and we just got in there as quickly as possible and staked our claim. So we have the SETS lab, where we have all our ergonomics equipment, and then we have what's called a CanLeap facility. I'll be speaking to that a bit later, but that's a large obstacle course that we actually have built indoors within our buildings. And again, we have an assortment. We've tools, anthropomeasuring tools. We have 3 large laser scanning systems for scanning the whole body, heads, hands, and we use the hand scanner for the feet as well, or the foot, sorry. Conversely, we use the foot scanner to scan feet. No, hands, whatever. We use one scanner for both. We also need a lot of software to analyze it. Motion capture is very important as well. So we have 3 different types of motion capture capability. The inertial mocap, it's similar to, I don't know if you're familiar with XNs. Again, if we want to look at mobility of soldiers wearing a lot of equipment, we can't use optical motion capture because you would just end up tracking the movement of the equipment on top of the body. We need a system that will fit underneath this equipment and track the true motion of the body. So we use the inertial mocap. And there's the Qualisys, the ProAnalyst. We have a full biomechanics capability now, and recently we've hired a biomechanist. It's a 2-year term. Hopefully we can move that to a more permanent position, but we're really ramping up our biomechanics capability. We have some other testers as well for up here in the top right-hand corner, you can see a load carriage simulator. And almost as important as all the equipment we have is that it's really important that we develop networks of partners and collaborators. We can't do all this work alone, and there's just too much work to do. And we need to go out and find the best and the brightest to help us move along. So we have very strong partnerships with industry, academia, other government departments such as National Research Council, but we also play quite a bit within the international scene. So the TTCP is a 5-nation collaboration panel, and NATO. We're always involved in some sort of NATO activity as well. And that helps us do what we call burden sharing. We take a piece of the pie, you take a piece of the pie, we'll work on our pieces, put it together, and hopefully come up with a complete solution. So I'd like to talk to you a little bit about the Canadian Forces Anthropometric Survey. This was the first big undertaking as part of the SETS project, and it really serves to update poor, updated, or non-existing data. So let's just go here. This slide just basically explains, hopefully, what this isn't anything new to anybody out there, but anthropometry is very important to the Canadian Forces. It's used to specify, develop, evaluate equipment, workspaces. There's new ships that are being procured. So how big should the living spaces be? How big should the hallways be? How high should the sights on optical systems be? Crew selection. I mentioned the anthropometric selection for pilots in the Air Force, but also tankers or tank drivers are screened. It's a very tight and restrictive space to be working in, and just not everyone can do the job just because of the physical restrictions. So what happens when anthropometry isn't properly or well considered in design? Well, we get things, situations such as this. These are really horrible looking injuries from just poor fitting boots. Soldiers spend a lot of time carrying tremendous loads on uneven terrain. You can imagine if the footwear is even just a little bit off or restrictive, we have all sorts of injuries. And there's a book going back to 1917 that I quote on the slide called On the Soldier's Foot and the Military Shoe, which goes into great detail about proper fit and the consequences of improper fit on military operations. So this isn't new stuff, but we're still working on it almost 100 years later. Accidents. One of the things that I consider when I'm doing aircrew evaluations is the ejection seat aircraft. Is the pilot able to clear all the structures within the airframe if they ever need to eject? So this slide just shows an F-16. It's a mannequin, it's not a real person. And you can see on the way out, there's a knee strike on the canopy bow. And this is definitely a career-ending injury for any pilot who ejects. So we need to ensure that the pilots, the leg length, the seated height, etc., is within acceptable limits, so that they're they avoid any injury on ejection. Suboptimal performance. This is actually a photo taken of a military ambulance. So think of loading, unloading, patient care when you're in this type of a restrictive environment. Costly workarounds. I can name a number of issues where things have been done and it's caused issues or restrictions of accommodation and analysis. It's much cheaper to design properly and prevent a problem than to fix a problem after it occurs. Let's leave it at that. And here I just have a clipping from a newspaper regarding the air ambulances. I think a lot of people are familiar with that orange-colored helicopter. Well, it turns out that human factors was not, well, I guess was the first casualty in this acquisition. When loading the patients into the helicopter, the ceiling height was so low that the medics weren't able to do chest compressions. So there's a period when you're maneuvering and sliding and setting them into there, you can't take care of the patient, and that's really a tragic situation to end up with something like that. Another thing is you end up with the Sperry ball turret. This is a B-17 Second World War era. Just a marvel of engineering, but you can see the enclosed space that the gunner would have to fold themselves into. It's about 3 feet in diameter, and flying at 30,000 feet with all your heated or your winter gear, trying to operate this ball, it's a really let's call it interesting space. You can see here at the belly of the aircraft is where the ball gunner would sit. And finally, just I don't want to belabor the point, but more recently, with the loss of the space shuttle program, I think this is actually documented in Chris Hadfield's book, that the Soyuz, the Russian space capsule, is now what they're flying in. You can see it's so restricted compared to the space shuttle that a lot of American or NASA astronauts could not fit into the Soyuz spacecraft. So there's a potential that they would not ever have an opportunity to go in space. Fortunately, they've made some amendments or modifications to the Soyuz to open up the space a little bit, and now more astronauts, cosmonauts, etc., are actually able to fly within that spacecraft. So all these problems that I just mentioned are things that good current representative anthropometric data can benefit in minimizing the risk and addressing these issues. So when we do an anthropometric survey, we need to think of a few things before we go ahead. The first off is obviously who's your target population. Are we designing for everyone? Are there special groups that we need to be aware of? So just a really quick summary, we know that there's a strong race and ethnicity component to anthropometry, and this top right diagram is taken from Roger Ball's Size China survey, where they did 3D scans of heads in China, and you can see that there's a very different shape between Western and Chinese heads. Male and female, if we look at sex, occupation. A paper here in 2002 demonstrated that agricultural workers, even if you control for age and ethnicity and that, have very different body types and shapes than first responders. So you would design very differently you wouldn't use agricultural worker data to design protective equipment for firefighters, for example. We do have those types of distinctions within the armed forces, for example, combat arms, infantry, artillery, etc., tend to be younger, fitter than, well, I don't know about air crew, but maybe administrative, clerical staff. So we need to have a good representation of combat arms and its specific occupations. Also, we know that there's age-related changes as well, so we need to make sure that we sample appropriately across the full age. And what that really tells us is that there's a large variability that we need to account for in any population. Let's skip over here. We know the populations are changing. For instance, here's the MRIs. Since 1997, they've gradually been making them bigger, supporting more mass just to accommodate a heavier population. Recent article from China that they did a survey, and this is no different than any other military survey that I've seen, is that the military population is getting bigger as well. So what's the implication on all the existing equipment and vehicles, etc., that they're using? And down here in the bottom right, the mill standard 1472, as far as I'm aware, it still uses data from 1988 from the American Anthropometric survey. That data, it's not representative of the Canadian soldier, and it's probably not representative of the current U.S. soldier either. So there's a bit of a lag in getting good, recent, up-to-date data in the guidelines. So time for a joke. You can read this, but yeah, don't bring this up at home. So a little bit about the survey. Again, there was a very strong need for a new anthropometric survey. The last survey was done in 1985 for the Air Force. That was done on pilots and aircrew, males only. 97, a land forces survey was done, and for various reasons, sampling and that. And again, it was just land forces. It may not be representative of today's population. We've never had data for the Navy, and we know that we can't, because of ethnocultural differences and that, we can't use data represented from other surveys. So a survey was done in 2012. And this is an overview of the sampling strategy. We had 4 categories: sex, occupation, age, these are sampling strata, and francophone, non-francophone. So that's sort of our ethnicity component. The reason that we did that is that we have some very strong evidence from our clothing directorate who indicates that their sizing schemes and tariffs are very different for Valcartier in Quebec than it would be in Edmonton. They tend not to issue larger sizes in Quebec than they do in Alberta. So they're interested to see, is this just happenstance, or is there something real to this information? We did a lot of demographics, landmarking. We did traditional data, so this is data measured, with an anthropometer, but also 3D laser scanning as well. 3D is, I think, really the way that most surveys are going to be going in the future. It's pretty well standard practice now. And it not only provides you with a permanent copy of the participant, but now we have all the size and shape data together that we can analyze. We need to still do traditional measures. First off, if we want to compare with previous surveys, we should have some data that's measured in the same manner. But also you can see in the 3D scans that there's often voids, there's some noise in the data. If you extract a measurement from a 3D scan, it's not going to be the same as a traditional data. So the survey, we did target, 1,000 per service and 1,000 females as well. That would be our ideal perfect world based on a power analysis. However, you look at the map of Canada down there and all the locations that we travel to. Imagine sending a team of 14 measures, all your equipment far and wide, to small bases that only, it's really hard to get a massive sample. So, but we were very successful. 2,200 individuals, so 316 females, 1,890 males. So we have a very, very strong data set, particularly on the male side. Females, it's a very small portion of the Canadian forces. It's very difficult to actually get strong numbers out in that area. But demographically, our proportions were pretty good. 13.7% females out of the Canadian forces, overall of 14.7%, so proportionality were fine. We also had strong sampling from combat arms, pilots, aircrew. So those were our target occupational groups as well. So we did a good job, and I think we have a very, very usable and robust data set. So the 1D data. So 1D data is a traditional data, of course. So within the report that it's just almost out of the publication process, you'll have lots of tables with percentiles and descriptive stats and descriptions of how the measurements were taken. So that will be out for use fairly soon, general use. If we look at some of the results here, this is a plot showing the comparison of the 2012 survey to the 97 land forces survey. Land forces survey are the red markers. We can see that the 97 survey definitely underrepresents today's population. So we have stature and weight on the left. We can see that they're a lot more heavier, maybe a little bit taller, but overall our Canadian forces tend to be a bit heavier. And if we look at waist and chest circumference comparison, we can see that the plot's heading up into that upper right quadrant. So there are a lot more large individuals than we had identified in the 97 survey. So this is very important. So any systems that are being specified using the 97 survey are being under-specified. I just have some little dots here just to show some of these crazy outliers that we have. This is the tallest individual that we measured at just about 2 meters 12. And the smallest is about 1 meter 50. And looking across all the services, we can see that Navy tends to be a little bit heavier, understandable, being out at sea. North Atlantic, whole different type of occupation than Air Force or Army. And here we see that pilots tend to be not about as tall, but definitely a lot lighter than the other crew. And this is really a factor of just the anthropometric screening that pilots go through and the necessity to be smaller to fit in certain airframes. Now, there's always been discussion that we can't use military data to represent civilian population, and I think that's definitely the case. But here I'm just looking at the 2012 Canadian Forces data in red versus the CSER, which is a European North American survey done in around 2000, that those combination ellipses, so these ellipses encompass about 95% of the data in each. They're starting to get a little closer. Then again, 2012 data, for all I know, that's out of date, and that ellipse should be larger than it is right now. But it's just interesting to see that there's not a biggest difference as I've seen in other comparisons. Now, just to talk a little bit about our 3D scan data, this is what our 3D scan data looks like. So we have little videos here, so we can turn them around, and you can see that you get full representation. We have this nice grayscale overlay, so we can identify landmarks. So all the participants were landmarked before being measured and before being scanned, so that we can actually now make specific measurements from the body. With a 3D scan, it's really hard to palpate a bony landmark, so we have to do that before we do anything else. And this is how we parameterize our models by having the scan, but also anatomical landmarks predefined as well. And we have some feet and hands here as well, so you can see what they look like. So now that we have all this data, we have to make some sense of it. As I mentioned before, if I gave you a bunch of tables of various percentile data or a spreadsheet full of numbers, oh, that's a little better than the tables. It's, well, what do you do with it, and how do you make good sense out of it? The first thing a lot of people do is, well, I want to know percentiles, and yeah, the tables give you that. But percentiles should only be really used under very specific circumstances. And I'll tell you what, percentiles aren't really the best. Hopefully, many of you know this. I don't know how well the message is getting out, but percentiles are great for one body dimension, not for multiple body dimensions. And here's just a simple diagram. If we measured somebody here on the left, and we took the, well, let's say this is the 50th percentile of ankle height, knee height, crotch height, hip height, etc., added it all up, you would get 77.4 inches. If you took the, what did I say, 50th percentile human and measured them, they would be 73.5. So percentiles are not additive. If we're talking about a 50th percentile mannequin, SAE mannequin or whatever, they are not 50% on every dimensions. They usually start with a stature or a weight or something, and then do some hierarchical regression or some other technique to estimate what those other body dimensions should be. But yeah. So the other thing is, if we're working with multiple dimensions, it's not additive for accommodation. So these are 5 dimensions that we often use for a workstation design. And if I wanted to specify, well, you know, I want the system to be designed to accommodate the 50th to 95th percentile sitting height, buttock height, check all the way down, we can see that, well, if the 90th percentile, or sorry, 90% of the population is accommodated from the first sitting height factor, well, only 82% of that population is within 5th to 95th on buttock knee length, 78% is 5th to 95th on knee height. So when you think you're starting off with a 90% accommodation rate and work your way down over multiple dimensions, you're really down to about 67% actual accommodation. So I have a little point here that says you should only use percentiles when one body dimension is considered independent of all other body dimensions. Now again, if you had a seating system that was fully adjustable in every dimension, well, then you're actually looking at your dimensions independent of the others. So percentiles would be fine in that case. But really, where most of our days are spent are in the multivariate accommodation world. And I'm just really happy to announce here that in the latest military standard, the human factors guidelines for the military, 1472G, they finally got away from the 5th to 95th percentile and mentioned that multivariate analysis methods are required. And we only use a univariate or percentile approach under very specific circumstances, and it must be justified and documented. So we're talking now about a central 90% accommodation of users, not 5th to 95th percentiles. This is just a really quick slide here to show that when we do work with, let's say, 2 dimensions, and we're looking at 5th to 95th percentile, so we have the leftmost and the bottommost line is the 5th percentile, and the topmost and rightmost is 95th percentile. If we're looking at accommodating that population, we can see that looking at various combinations, there just isn't anybody that's a 5th and 95th, 5th and 95th on these 2 dimensions. So here you're trying to accommodate people that don't exist. So again, what we do is we plot our data, we specify, this is in this case a 90% probability or accommodation ellipse. And based on that ellipse, you can pick your max and means for the population. Or if you wanted a family of test subjects, you might want to select points, boundary cases are called, around this ellipse, and test your design against these edges. The assumption is that if you can accommodate the edges, you can also accommodate the middle as well. I tend to like to pick a centroid as well for my test. Now, what happens? Oh, sorry. This is an example of I just pulled some NATO sizing for a shirt off of the internet and plotted it against our Canadian Forces data. And right away, I can see by plotting stature against chest circumference, which is the sizing screen, that, you know, hey, it's not too bad. It actually lays somewhat over the population. I've seen other sizing schemes that only 30% of the Canadian Forces population actually fits within the sizes that the manufacturer provided. However, there's this.
Just a quick interruption. Sorry,
sure.
Alan, just a quick interruption. It doesn't look like your slides are keeping up with the speech. What we're seeing still is the military standard slide.
Oh, okay. So
I think you're a couple of slides ahead, maybe to.
Oh, okay. I'm sorry.
No,
so you're on.
I'd let you know.
Are you? Can you? Are you on a plot now?
We're on the slide that says the military standard 1472G.
Okay, so I've just advanced the slide.
Okay.
Anything there?
No, it's still the military number there.
Oh, okay. I'm sorry about that. I've been blabbing on, and
No worries.
everyone's
I
wondering
probably
what's.
just thought that your speech is not probably consistent with what you were looking at on the slide.
It's completely inconsistent with what I was talking
There
about.
you are. Shows that we are listening, right?
I was wondering. It was a little quiet out there.
We are out here. We're listening to you.
Are there any questions just while we're waiting for the screen to update? Or
Not so far. I mean, there was a few pop-ups concerns about the inconsistency there with the slides, but no questions so far. Yeah.
Okay.
I had a couple of questions. So, the actual sampling, is it done by people that are volunteering, or are they appointed? Are they personnel that are appointed to be sampled?
In this case, it's a bit of a voluntolding and strategic sampling. So if we just had people showing up, voluntarily, we know that you tend not to get the extremes. People that are larger or smaller or uncomfortable with their body image, for example, tend not to put their hand up and say, "Yes, I'll strip down to my underwear and have strangers measure me," for example. Right. So you end up with so the approach that we took is that we used a tasking process within the Canadian Forces, and we tried to task entire units or groups to come out. So all hands that are available today that aren't doing other things show up.
Okay.
And so that's really the best we can do. And you do have there's operational reasons why you can't get everyone, but that's the best that we could do. Has the slide advanced at all for you, or?
I'm still seeing the military standard slide.
Okay.
I have some messaging coming through that some of us can see the slide okay. So, what is the slide that you're seeing on your screen at the moment?
Oops, sorry, I'm playing with it. Right now I have a multi-dimension problem slide.
Okay. A couple of people are saying they're on the multivariate accommodation slide. So I think it's just some of us that are still seeing the standard slide like I have, and some are sort of on your page. Yeah, interesting. The responses I'm getting are some are still on my page and some are on your page, so I'm not really quite sure what's going on with the system there. Can you try going back to the military standard slide and then forwarding again? Perhaps we go back and then we go pick it back up again?
Yeah, I can do that. Oops, let's go back into. So she's still on. Slide's still in Winnipeg. Oh, sorry. The person is the person in Winnipeg, or is the Winnipeg slide? Yes. Okay. So I talked about Winnipeg a long time ago when I showed a map of.
Can it help to maybe shut down the presentation, bring it back on, maybe? Maybe that helps. Do a refresh. It looks like participants are signing out and signing back in to see if they can fix it from their end, but it looks like maybe we need to just, somehow the presentation is frozen.
So, how can we? How can we fix this? If I try to upload the presentation, I've made it quite a bit smaller instead of running from my desktop.
We can see your cursor moving. So
okay.
Level of function here.
But nothing's coming through the.
Nothing's going through the system.
Shared document. Let's.
Maybe if you have the opportunity to shut down the presentation and reopen.
Sure.
Reboot it.
Have you tried a hammer? No, not yet.
Not yet.
That's the next.
That's our last solution, right?
Yeah. That usually works. So, sorry. So let.
So we're seeing upload in progress at the moment. Okay, our presenter is just online for the moment, so I imagine that he'll be back very shortly. So, apologize for the interruption here. I guess the difficulty with technical systems sometimes. So as soon as Alan comes back online, I'll invite him back into the room, and hopefully it'll work. Hello, Alan. Welcome back.
Hello.
Hello there.
Hi there.
Welcome back.
Are we back, and did things clear up a bit?
We're back, and yeah, so far I can. Your screen seems to be uploading. The PowerPoint seems to be uploading. Yeah, I can see your main website now.
Okay, so what I'm going to do is just click over a little bit here and pick up at a point that's worth starting out
thank
here.
you for your perseverance on this. Because
Thanks very much.
Not see what it is you're talking about.
Exactly where we're going here. So, okay, so do we have multi-dimension problems?
That's what I'm seeing right now. Yes, yeah.
Okay.
The feedback we're getting is good, perfect. So I'm going to switch off my mic and let you carry on.
Okay. Oh, okay. Sorry about that, but hopefully we're back in business, and I'll try not to do anything too fancy, because I have a feeling when I run a video or something, it just chokes the system. So just to get back where we left off, I was talking about we need to move on from univariate 5th to 95th percentile measures and move to more multi-dimension. And this is just a simple plot here that shows that sometimes we need to consider more than 2 dimensions concurrently. For example, this is if we're looking at designing hatches for an armored vehicle, the chest depth and shoulder breadth and that are very important to get through. So if I took those 2 dimensions and plotted the 5th and 95th and looked at mins and maxes, you can see in the upper left and lower right, it actually takes us into a space where the population doesn't exist. It also doesn't represent the true extremes of the population from a distribution standpoint. So if we take those little circles away and we plot our data, and with a 95th percent accommodation ellipse or percentile ellipse, we can see that we still accommodate 90% of the population, but more representative of its true distribution. I have some blue stars here that just show us where the mins and maxes are within the distribution. But we may also want to take points along that boundary case or around the boundary of that ellipse to select test participants. The philosophy is that if we can accommodate those along the edges of the population, we should be able to accommodate those in the middle. It doesn't always work that way, but that's the best step that we have right now. Here's an example of how we've actually used the bivariate plot of data for looking at clothing sizing. This is a combat shirt. I just pulled the NATO sizes off the internet and plotted it against stature and chest circumference of the Canadian Forces population. And we can see that it fits pretty good, the boxes. So this would be one size, two sizes, three sizes. You want them to be on top of the population. I've seen incidences where manufacturers sizing, we had less than a 30% overlap between what the manufacturer sizes were and what the Canadian Forces actually look like. But what we can see from here is that we have a little gap at the right-hand side. Oops. And we really need two additional sizes to fill that population. We may even not want another size out here to capture the extra large sizes. The reason, you want to minimize these people that aren't in the box, because to do special fits, custom manufacturing clothing for these individuals, or buying one or two sets of clothing can be very, very expensive. So you want to know exactly what your sizing scheme and tariffing. So tariffing means what percentage of size medium and what percentage of size large, for example, do we need to buy. If you have that information up front, you can achieve a great economy in procurement and manufacturing of clothing. So this is an example of a tool that we've developed that'll be distributed with the CFAS data set. And it's hopefully we're going to migrate this to a web-based platform as well. But this is just a really quick access tool that we're pushing out. So it allows us to plot univariates. You can get histograms of any of the data. You can do queries on any of the demographic data that we've provided. And if we look at a bivariate plot, it plots the data. You can specify the ellipse, but it also will identify boundary cases around that ellipse for your test subjects and provide the dimensions where those boundary cases are. So this is really our first attempt at providing a tool that is usable and understandable by our end users and gets away from just lumping a bunch of data or tables and saying, here, have at her. The next area that we've been working in is principal components analysis. So we do PCA when we have more complex multivariate problems. And PCA is essentially a data compression method. And I have a diagram down here at the bottom that shows a scatter plot. And what principal components does, it will take that data and reduce it into discrete components, which I'm just reading off the slide here, explain a unique proportion of the variability within that data. So within this data plot here, we can see that you have a lot of variability along this axis, and 90 degrees orthogonally to it, you have more variability. But if you're looking at 40 body dimensions, you can't visualize it, but the PCA will break it down into 40 discrete vectors and called principal components. And each one of these components explains a certain amount of variability in your data. Typically, we just work with the first 2 to 3 principal components. And the example I have here, principal component 1 explains 67% of the data, PC2 is 24%. So right there you have 91% of the variability in your data explained with just an X and Y axis rather than a 40 degree or 40 degree type of axes. So we used this method recently to specify the dimensions of test mannequins for evaluating a cockpit of an aircraft. And this is just a small tool. I worked in Excel that takes some data from a stats package, plots the first 2 principal components. So we selected 6 body dimensions, which we determined to be important for for doing all the things that you need to do inside of a cockpit. We plotted our probability ellipse. In this case, it's an 80 percentile ellipse. We selected boundary cases. And once I select the boundary cases, I can do a reverse PCA and generate the body dimensions that are associated with that point here. So we come up with 8 mannequins, and this is what they would look like. So these are the mannequins that were put into Jack or Ramses or Katia, whatever, and they represent, well, the intent is that they represent the variability of the shape and size of the, in this case, it's the pilot, RCAF pilot population. Another more gizzy way of doing things is to actually use shape data, where before I had used dimensions. We're using shape data here. And this is a small tool that we've worked with National Research Council. It's called the Shape Analyzer. And hopefully something's showing on everyone's screen here. But this is a tool. So what we have here is an aggregate of approximately 2,000 scans. They've been fully parameterized and templated and modelized. So this is not one person. This is a representation of thousands of people. And we have the principal components on the right-hand side of the screen. And we can manipulate those principal components to look at. So I just manipulated one there. You can see that was size, overall size. Number 2, it's really girth and weight of the individual. And we can work with these principal components to generate a set of virtual shape mannequins as well. So if I just close that and show you, this is, I sort of position these at a little weird angle. They're not really, they look big on the torso, small on the legs, but this is a family of mannequins that we would develop for any type of application where we need to really understand the human shape, or some digital human modeling tools will allow us to import this whole shape model into their tools. Things that we need to do in the future are work on segmenting these models. For example, if I was just interested in designing protective armor for the torso, I really don't care about shape variability in the arms and legs. So we would cut off the arms and legs, do the PCA on the torso, and come up with shape models to design better curvature, better coverage of the armor for the torso. And here's an example of how we used shape models. This is head models, for example, what we've used. We've used the principal components, 3 principal components in this instance, generated a family of head mannequins, and this was used for helmet fitting. And again, the shape data gives us much more information than just traditional head breadth and head length. So there are a number of tools out on the market, and some are better than others, but we're working on customizing, developing a whole suite of customized tools based on what our particular requirements are, but also leveraging some of these tools as well. This Body Labs, this is some work that the U.S. Army had done, and it's work that we'd like to get into as well, where we're actually able to use motion capture data and model, animate our 3D scans. And this is very valuable if you're looking at mobility. Let's say we wanted to design, again, protective armor. If I understand how the body moves, where the real high mobility points are in the body, then I know that I can design a pattern that allows mobility in those areas, but is more rigid where the organs are to provide protection there. We can also do some basic, functional anthropometry, reach mobility in a virtual environment using this type of tool. So we're working on future model development in this area, and that's a few years down the road, but we're hoping to get there soon. Of course, with any tool, you need good guidance. So having a decision type tree built into the tool is important, where you can actually start off with a scenario or a case study and step your way through this tree of decision making for doing anthropometric assessments. and then the tree will lead you to the appropriate tool at the bottom, and hopefully populate it for you so that you're using the appropriate methods. The HBEST guidelines for anthropometric data is a really excellent resource as well, and we'll borrow heavily from that and other resources to augment the documentation and help design the tool based on best practices. So getting out of the anthro and just touching a bit on 3D scanning and clothing. This is a small project that I'm starting up. It's with a NATO group. We're looking at the use of 3D scanning for clothing fit and logistics. So we can, right now in the Netherlands, every soldier in the Royal Netherlands Armed Forces gets 3D scanned. And they use that scanning for clothing issuing. So you get scanned, the scan is automatically measured up. It comes up with a list of clothing sizes. Canadian Forces use a similar type system, but it uses a photogrammetric system as opposed to 3D laser scanning. With the 3D laser scanning, we can use that data to inform patterning. We can do virtual fit testing. So if we look over at the right here, there's a heat map that shows based on this pattern, this is how the clothing fits, the snugness of fit on the individual. Or we could run it against a population database and see how well it fits across a wide range of shapes and sizes. For everyone that has let's say a 32-inch waist, you're going to get a wide range of buttocks and leg lengths and everything as well. So this is a good way to do a virtual assessment of that. And here again, we're doing virtual fit testing as well. And we can see that just because your data point falls within a certain sizing doesn't mean that's the sizing that's going to be best for you. For example, if it fits the waist but a little tight in the buttocks, you might go up one size, you might go down one size depending. So the virtual fit testing allows us to do those types of evaluations. Encumbered anthro, again, I mentioned that we don't fight in our underwear. So encumbrance is always very important. Just because of the amount of equipment that the soldiers would wear. In the past, encumbrance was usually accounted for by offsets. So if you're designing a seating system, you measure what the maximum hit breadth is, and then, okay, so they're wearing a frag vest, okay, that in areas of the chest, we might add 7 or 9 millimeters. Yeah, so this is, it was just a simple measure. But you can see from the diagrams here that where the bulk of the clothing is not really referenced well to any traditional anthropometric landmarks. The shape of the individual varies with the load, the equipment, the underlying anthropometry. So your tall people and short people, the load will sit differently on them. So we need better models of how to understand how the encumbrance changes the affects the body's shape and spatial plane. So this is work that Monica Jones, I guess many of you may know her. She was a postdoc with us. She's off at University of Michigan, and we're all very sad that we lost her. But she started this program developing a framework for encumbered anthropometry. And it really hinges on 3 components: the bulk or the spatial claim, the weight mass distribution, and the stiffness of the clothing. These are all 3 aspects that we need to model to help understand soldier performance. But also, if we want to move to a digital human modeling environment, that the encumbrance needs to be parameterized according to these 3 factors to really do a proper representation of the restrictions of encumbrance. And here's just an example of how some of that work is done. We're just using a lot of MATLAB shape analysis tools, and just some interesting programs here to come up with simple parametric models that are computationally simple, but also adequately represent the size and shape of the individual and their clothing. Soldier equipment and mobility. So spatial claim is one aspect, but also the functional aspect of wearing clothing and equipment. We need to understand that as well. So here we've just 2 examples of how we go about measuring encumbrance to motion. First, this is a simple motion capture. I'm using ProAnalyst here and a GoPro cameras where we digitize an individual going through various range of motion activities. But on the right here, we're now using a biodex system. So biodex is essentially like a Cybex and isokinetic dynamometer, where we have our soldiers wearing various levels of clothing and equipment go through various ranges of exercise. And essentially the delta between their performance in their shorts and t-shirts versus full fighting order gives us an indication of the resistance of that clothing to motion. And then we have finally, this is a CanLeap course that I mentioned earlier. So it's an instrumented obstacle course. This system was developed by one of our very close partners, Human Systems Incorporated out of Guelph. It was done in conjunction with the U.S. Marine Corps. I'd like to also acknowledge that Human Systems was very instrumental in helping us with our Anthro survey as well. They did a great job in the design and logistics of that study as well, so thank you. But yeah, this is the course as set up within DRDC and gives you an indication of the type of obstacles. They're operationally relevant obstacles. Soldiers run through, every obstacle is timed, so we have very good data as to the impact of various levels of encumbrance and weight soldier burden on their ability to do various activities. And finally, we're getting into virtual digital human modeling. This is very, very important to us. It provides us an ability to do what-if scenarios, that initial design specification. We always verify our models with human testing. There's just some limitations built into DHM that we can't overcome. But the cost savings, the safety, etc., that we do in digital human modeling is tremendous. And it's our goal to try and improve these models as best as possible using Canadian Forces specific data to bring it closer to the ground truth. We also do some digital human modeling here. This is more biomechanical modeling. This is some work that we're using Visual 3D mocap to model shooter response to weapon recoil. So this is just a screenshot of some work that we've done with the Leopard tank. We put in a new suspended seat. So what are the impact on head clearance, eye clearance, so the episcopes, mobility? You see that the model is not encumbered. Again, that's one area that we need to improve the digital representation of encumbrance. But this is just simply how we would use the tool in this case. A bit more fun to watch is some work here that we're doing looking at neck strain in helicopter pilots. And it is a really big concern, particularly because of the extreme motion. So here we have a flight engineer checking underneath the aircraft to identify if the landing zone is clear. But they have a helmet, they have very heavy night vision goggles, there's tremendous forces on the neck. So we used a motion capture system to parameterize their motion. And then, oops, sorry, that previous video was just showing how we had incorporated or using our motion capture library to drive models in Jack to get some additional kinematic information. Hopefully, these types of techniques will lead to a future project in advanced aircrew accommodation, where we'd like to do a better job of doing virtual representations of aircrew in cockpits. So we have some work to do in defining postural models, actually putting humans in aircrew seating, so we know how to posture the mannequin when it goes in the airframe. Seated functional reach studies, we need to digitize the cockpits, and also finally a fit mapping exercise. So that's when we actually put real people in the airframe and verify how well it compares to the digital representation, and are there any tweaks that need to be made. So that's pretty much a wide swath of the work that we do at DRDC in this area. Just some future work that we have planned. Definitely we're firing our project to get the web-based tools underway. Drafting guidelines and standards for the Canadian Forces and the use of anthropometric data that will complement these tools. Working with National Research Council on advancing, that 3D shape tool that I showed you is really just the step one of a longer research project to advance the use of 3D shape models. in our anthropometric modeling, encumbrance, DHM, digital human modeling tools, and also very important is enhancing our partner network as well. We definitely need to tap into a lot of that expertise that's out there in the world and get more partners on board to really provide us with the horsepower that we need. To be honest, we're only 3 people in our lab, and you can see that we've been able to accomplish quite a bit, but you always need some more work. So real simply, the summary, anthropometry is important. We all know that. It's very important to have data that's representative of your population, and the 3D data really advances the use of anthropometric data, or just what you can achieve with it. We need to have good tools that also help us to understand and use multivariate 3D shape models. Those tools are being developed, and digital human modeling needs to be to better represent encumbrance and basically military operational environment to model accommodation and task performance. So I'm going to stop it there. I'm sorry I told you I was chatty. I went a little bit long. I hope I haven't bored everyone to tears, but I'm willing to I don't know, face the firing line.
Hello, Alan. Thank you so much. That was very informative, very, very interesting. So there are a couple of questions. I don't know if you can see the Q&A box from your side, but Becky had some few questions here on the MIL standard. And she asks, does this mean that the MIL standard will show the percentage of population included in the percentiles?
No, the MIL standard just indicates that the central 90% of the population needs to be accommodated. Within the percentiles, again, if you were just designing the height of a ceiling, if you use the 5th to 95th percentile for stature, that would give you your central 90%. But it doesn't tell you the methods or the tools that you would use otherwise to determine the central 90% of the population.
Okay.
I don't know if that answered the question, but
we'll see if she totally responds. She also asks, version EF, I guess of the standard again, only includes the percentiles, and there is no information on what the volume of population are outside those percentiles.
Right. Yeah, that's definitely a limitation of the MIL standard, and again, it's all based on 1988 U.S. Army data. So what we would do is use those guidelines and then provide, the tools that we're developing to do that analysis to tell you what that outlying population would look like. So you really need to work with the raw data set, in my opinion. So with our tools, we'll be populating it with the Canadian Forces data, but I'd like to have the database open enough that we could really insert any other data set into it, or multiple data sets, and have a much more robust tool. Yeah. But the MIL standards are just they set standards and guidelines, but they don't really help you a whole lot with the analysis or what to do with the data. Yeah.
She has one more question here talking about, does the 1472G include the percentage of population that is captured by the 5th to 95th percentile measurements?
Not well. If again for a single, if you're just worried about a single dimension, like stature for ceiling height, the 5th to 95th, you'll know will capture 90% of the population. But if you're looking at more of a multivariate solution, no, you have to go back to the raw data and use that data to calculate what the percentile accommodation would be.
People were sort of typing in to say thank you so much for a great presentation. I had one quick question for you, Alan, around the procurement aspects. Now, you were talking earlier about the helicopter, of course, that came that didn't quite fit the function of doing, emergency response treatment on the way home. During the procurement process now, do they consider the anthropometry at all? Like, does that consultation now happen before any procurement process?
Yes and no. Unfortunately, Canada is one of the few nations in the world where human systems integration is not a mandatory requirement of the procurement cycle. Now, that doesn't mean that it's not considered. It is quite extensively, but in the United States they have a okay. I'm having a seniors moment, but there's a whole program where they look at the system view, the mobility, firepower, electricity, and then there's the human view, and the human systems integration is a major part of their program. Mm. In Canada, it's a little bit hit and miss. I worked on some projects where we've done a lot of work on anthropometric data, and they said, well, it's only worth a few percentage points of the whole bid, okay. So it may or may not matter. But many other systems, they do very extensive human factors testing. So there's a strong effort now to put together a human factors or human systems integration cell within national defense to ensure that there's much more rigor and the human is considered more closely in procurement.
That's good news. There's one question here from Jennifer.
Yeah. Oh, absolutely. We've been fighting for years.
There's always some challenges in every occupation.
Hey, Jen.
There's just a quick question here from Jennifer.
Okay. Yeah, it's like selling ergonomics, right? Yeah.
One quick question from Jennifer. What is the time frame when encumbered models will be available for DHM tools?
That's a good question. I know that Matt Reed, down at University of Michigan at Umtree, they've actually been putting some encumbered models. I thought that was going to be in a soon-to-be released version of Jack. I don't know if it's a publicly released version of Jack, or a specific module for a military client. So what we're trying to do is latch on a bit to what the big guns are doing and Canadianize the data. So it does seem to be coming in Jack. But our biggest challenge is we can't dictate which digital human modeling tool needs to be used for any procurement. Not everyone uses Jack. Some use Ramses, some use CATIA, some use Human Builder. So we need to really figure out how to do more a generic framework for encumbrance. Now, I know, Jen, that US CAR, there'll probably be some discussion on this matter as well, but I still think it's a little bit of a ways off yet to properly do it. It's a very challenging problem to get our heads around, but we are making good headway.
And there's just a question here from Anne Christina. The examples that you showed had two main PCs. How do you proceed with three or more equally distributed?
Well, with three, you would use an accommodation ellipse as ellipsoid, and pick boundary cases around the ellipsoid. It's very rare that. If when you're getting into more PCs, in my experience, the first three pretty well cover a large majority of the variability in the population. If I didn't show the program, but if I can launch that quickly again, you can see here that once I'm down to principal component 6, we're down to just about 2% variability in the population. So it doesn't, or in the data, so it doesn't really add a whole lot. Here's number PC4 is essentially useless. It's just it's teasing out postural variability. So there are mathematical constructs for the PC. So you might not how to plot it. You can do it mathematically, but it's impractical to go to much more than 3 principal components. But if we wanted to compress and then decompress our data, you'd want to go to more components to fully represent and not lose data. Sorry, it's not a very good answer, but for all practical purposes, you wouldn't go to more than 3 principal components, and I haven't seen it done in anything other than more mathematically theoretical papers.
And
there's a good paper by Brolin from, it's not Lund, yeah. Oh, when will the data set be publicly available? Good question.
Yes.
I definitely need to get everything sorted out in our publications process, and hopefully that will happen the next month. How we're going to roll it out, we haven't quite decided. Right now, it's mainly internal to the Canadian Forces and to some industry that are working on specific projects. However, I really would like to push the data set out to, you know, if we can get it populated in Jack and Katia and Ramses, you know, so the data sets are within the tools. And also our tool would probably be, parts of it would be publicly available as well. So it's a bit of a process. You know, give me 6 months and we'll have our heads around it a bit more and work out all the process. The problem is just where do we host it and how do we manage it to that. So, but I want this data to be publicly available. It's not a secretive special data set for special people, but yeah, it's coming.
When it is done and released. But Sue is asking about getting a copy of today's presentation, and the presentation today has been recorded. So once that's been set up, there will be a link on the ACE website for you to go back and review the slides. And she's also asking if there's a plan to look at the ergonomic requirements for the new naval ships in development. And also, is there a plan to examine gender differences specifically in the 2012 data sets across Navy, Army, and Air Force?
Yeah, so there's definitely a lot of ergonomics. We were asked to help out with some of the Navy, particularly mobility on ships, defining passageways and looking at firefighting and that type of thing. But we just didn't have the capacity, and the timelines to actually do the work was a bit longer than what they're on right now. So there are military personnel within the procurement projects with ergonomics background. They're biosciences officers who are going over all the ergonomic specifications for the new ships. So it's definitely habitability is always a big concern. And I know that there is a lot of work being done in that area right now. With regards to examining gender differences, love to do it. I just don't know with, we have 315 females across all the Canadian forces. In my opinion, it's not enough to do to look at differences between Navy, Army, and Air Force at this point. But yeah, I don't think we can realistically do that data set or do that analysis with any strong statistical power.
Okay.
I don't suspect there would be big differences across the three right now, just because of the very, very low number of females in what we call the hard trades, such as combat engineering and that, or sorry, combat arms, where you'd expect to see little differences. It's the females are sort of scattered across all occupational groups. So yeah, I don't know if we'd see anything. But we're just definitely lacking data in general on females in the Canadian Forces.
Well, thank you, Ollie. That looks like that captures all of the questions. And again, we really appreciate your time. The Association of Canadian Economists, like I said, like to host these type of sessions, and yours has been very, very valuable and informative. And we thank you for your time and expertise today. So I'm just going to end the recording on the meeting.